100 warriors looks scary, especially for the first slide, but today we're going to talk all about X-rays, and many of you might have heard certain interesting characteristics and properties of X-rays, like how it can pierce through human flesh and not through bones, and that's how you can detect a fracture. So highly penetratable. Oh my god, look at that girl out there who is getting her X-ray done. Looks like she's just fine. So all of this with me, your physics master teacher at Vedantu, going live. Hello my lovely warriors. Hi Anish, Akash, Blessy Joseph. Hi Sai Venkat, Anish, Janu. Hello Yogananda. Hello Prakash. Hi Om, Satpute. Hello Sneha. Good evening, good evening, good evening. Now those of you who do not know me, well, I'm Shreyas, and I'll tell you what we're going to do today first. So in this lecture of modern physics, which is also for term 2 and also an important chapter for JEE Mains, what we are going to do today is the properties and characteristics and applications of X-rays first. Then we are going to talk about how do you create X-rays using the Coolidge tube experiment, and then the two kinds of X-rays that you usually get. That's the characteristic and continuous X-rays, and then obviously the most famous Moseley's law, which reorganized your periodic table, and then X-ray diffraction, Moseley's and Bragg's law. All of this with me. I am so glad you guys are here. Looks like Akash is ready for a blast. Do I need teaching? Sir, I'm fascinated by chemistry. What to do? Then make it your strong point, Tushar Vishnu. As simple as that. It should be your strong point. Whichever subject you are good at, that should be something which you are going to get amazing marks in. So make sure that other subjects are at least till decent level, or else you will lose out in JEE Advanced. Okay, so let's begin. I hope you guys were there in my previous session of what to do to get 99 percentile. So guys, it's very easy. Just watch the class which I just conducted a few minutes back, and to get all the strategies, updates, sessions, one-shots, problem solving, mock tests, everything, you need to hit the subscribe button, and yes, shower your love by hitting the like button down there. Without that, I won't get the motivation. And this channel, along with Vedantu, will ensure that you guys succeed, you guys achieve your goal. Just like our students did it last time, thousands of them getting JEE Advanced ranks, thousands of them clearing JEE Mains with awesome, super duper mains ranks. All of them studying from Vedantu online. So if you are interested to check out our courses, it's all there in the description box. Make sure you use my coupon code so that you get a lot of benefits out of it. Let's get going. So no problem, you can definitely watch the recorded classes as well, Blessy Joseph. So GSK Telugu Gamer, simple timetable: in morning practice maths, in daytime read, revise, make notes, in the evening attend classes or do your other JEE assignments and homework, okay? And in the night do your other school homework, school syllabus and other stuff, and maybe just one round of revision. That's what you should do. At least you should study for 6 to 8 hours. Here's your first question. What do you guys think X-rays are? Are they a stream of electrons, or are they a stream of positively charged particles, or are they electromagnetic radiations of high frequency, or they are a stream of some uncharged particles? What do you think? Let's see. Thank you for all the love, GSK, Blessy. Thank you so much. Yogananda saying C. Good evening. Hi Sai Venkat. Sneha also saying C. Anish also saying C. Looks like you guys are C for correct. C for captain. C for captain. Yes, you guys are absolutely right. They are not particles, they are rays in a way. And you are going to study all the amazing properties of X-rays. Now, I'm not sure if you know who discovered X-rays, but there is a very interesting thing and story about how X-rays were discovered. You might have heard about how William Ronton discovered X-rays accidentally when he saw some photographic plates were getting exposed even if there was no experiment conducted around them, or even if they were kept inside a box, inside a cabinet, no matter what he did, he saw some photographic plates were getting exposed. So he wondered, what are these mysterious rays? So mystery means X. So he labeled these mysterious rays as X-rays. Later on he understood how X-rays are formed and how it can be applied for various purposes. So this is the original setup long time back. This is how it looked like. Crazy. So Longton discovered X-rays accidentally. It's crazy how people used to discover accidentally so many things. The only thing that happens accidentally these days is just an accident maybe. Okay, so let's get going. So what are X-rays basically? X-rays are nothing but light only, but just that they are not visible. That means they are electromagnetic waves. Remember, all electromagnetic waves can be classified into different categories. Some things you call as UV, some things which are seen you call visible light, some things are gamma rays, some things are infrared. So X-rays fall after UV and after X-rays fall gamma. So if you remember, infrared is very long wavelength, then you get ultraviolet which has very short wavelength, shorter than that you have X-rays, shorter than that you have gamma rays. If the wavelength decreases, frequency increases. If frequency increases, energy increases. So you can see the energy increases from left to right. We all know the energy of a photon. What is it given by? hf, Planck's constant, into frequency, or hc by lambda. So that's how it works. Everybody fine till this point? Very good. So only please tell, have I written the right question? Show that the electromagnetic wave is of a transverse wave. Is this? Show that the electromagnetic wave is a transverse wave. Yes. So basically, Ankit, all electromagnetic waves are transverse waves. One thing you can see, the field vectors oscillate perpendicular to the direction of propagation. That's one characteristic of transverse wave. Second characteristic, when transverse wave reflect from a hard surface, then the wave gets inverted. So when light waves get reflected from a hard surface, their electric field or magnetic field vectors get inverted, phase shift of pi radians. So these are all the important characteristics how you can distinguish a transverse from a longitudinal wave. Sabrish, you can definitely ask doubts relevant to the topic in the comments. If it is unrelated, leave it up after the video in the comment section. So below the video you can put it up. Okay. So they are very short wavelength, typically in Armstrongs. That means very high frequency. Very high frequency means very high energy. Very high energy, that means they can easily ionize the gas through which they pass. Very important. They can easily ionize the gas through which they can pass. So very important. They can ionize. Ionize means when they collide with that gas molecules, they will knock out the electrons because of their high energy. Next, they are also produced when it is bombarded by very high energetic electrons. That is what you are going to study in today's class, how X-rays are getting produced when you bombard them with electrons and you put a target material. Depending on the target material, you will get different X-rays. Also, they follow all properties of light. That means they will travel in straight line. They will also get diffracted if there is an obstruction. Also, they will not have any charge because at the end of the day, they are nothing but photons. And they will be able to travel in vacuum because any light or ultraviolet or gamma rays or infrared, they can all travel through vacuum. So basically, they have all the properties of your generic electromagnetic wave. It's just a small spectrum of the entire electromagnetic radiation. So of that entire electromagnetic thing, a small part is X-rays. Fair enough? Okay. Next thing, what are the uses? Let's quickly go to that so that then we can move on to Coolidge tube experiment. You might have seen that when you keep your flesh or your body in the path of X-rays, and if X-rays pass through your body, a part of it will pass, part of it will not pass. Your bones block the X-rays. So all those parts which get blocked by your bones, when you expose a photographic plate, you can figure out what's the structure of your bones if you have a photographic plate after it. Okay, only those parts will get exposed which pass. Some parts will not get exposed because bones are blocking them. And by these X-ray photographic plates, you can figure out how the bones are structured and if there are any cracks, or if you want to detect some anomaly. Also, they are used to scan your baggages and other equipment for security purposes. I'm so glad, Sai Venkat. What is the weightage of modern physics, Neha? It is very important. You can expect at least 3 to 4 questions in the JEE Mains, at least. That means you can expect around 20 marks in JEE. I'll tell you why, because there are some topics like photoelectric, atomic structure, which are also there in chemistry. So if you take that also into account, then it becomes 20 plus marks in JEE Mains, which is very, very important. So many applications are there, medically, security wise, detecting cracks, detecting fractures. So all of these are also mentioned in your NCERT. Make sure you remember that from your board's perspective. But I don't think they will ask much of it from JEE perspective, but maybe in CET, maybe in VIT EEE, maybe in BITSAT, I don't know, they can just ask. So you can just go through those application point of views of X-rays. Okay, let's do some in this short quiz out here. Akash, derivations are not so important for NEET. Unless you want full marks, then not full marks, above 150 marks, then you need to look for some derivations. Not all, maybe some. What will happen to the wavelength when the potential difference applied? Yes, we are going to talk about it, Yogananda. That's the next experiment. That's the Coolidge tube experiment. Okay. Yes, Anish, it can pass through skin and flesh. Definitely. It's highly penetrable. Okay, it can pass through most of the things like wood, cement. It can just pass through it. Very few things can block X-rays. Like one of them is bones. Okay, X-ray lies between which and which? It's very obvious. Okay, Sneha saying C. You can go back to the previous slide and I had just shown this to you. Look at this. X-rays lies between UV and gamma. Gamma is high frequency, ultraviolet is slightly lower frequency as compared to X-rays. So yes, the answer is between, do I have it over here? Yes, between gamma rays and UV rays. As simple as that. Yep, that's the first answer. Next question coming up on your screen. X-rays and gamma rays are both EM waves. Agree? Which of the following statement do you think makes sense? In general, X-rays have larger wavelength than of gamma rays. X-rays have smaller wavelength than of gamma rays. Gamma rays have smaller frequency than that of X-rays. Wavelength and frequency of X-rays are both larger than that of the gamma rays. Let's see how many of you can do this. How X-rays are created, Mohammed? I'm coming to it in the next slide. Okay, that is basically called as the Coolidge experiment. Yogananda saying option A. Come on guys, let's see whether you can get it. I think I just told this to you. Okay, some of you saying D, some of you saying A. Going back, I'll just show this right over here. X-rays have smaller frequency but larger wavelength as compared to gamma. Larger wavelength as compared to gamma but smaller frequency, because gamma rays are even more energetic. So going over here, so what do we have? Yes, in general gamma rays have, X-rays have large wavelength as compared to gamma rays or smaller frequency. So none of the other options will match. Sai Venkat, look at D. Wavelength and frequency both are larger. No. Frequency is not larger for X-rays as compared to gamma rays. Frequency is shorter. Hence the D option is not correct, bachcha log. Happens, it's okay. Sometimes you make mistakes, it's okay. Okay. So now let's answer the big question. How do you create X-rays? Okay. Now the setup that we need to understand and know for JEE as well as boards or NEET is that, X-rays can be created in multiple ways, but the setup that we study over here is the Coolidge tube. Very interesting setup. Here you have an anode and then you have a cathode, and what happens is there is a filament. That filament is basically going to pass, there is some current which is going to pass through that filament. Current means flow of electrons. Filament means something which can probably act like the source of electrons. Now what happens is there are two sides across which you create a potential difference. Now what happens when you create potential difference. Everybody knows this? So if you have one region of high and low potential difference, you will have electric field which is created. And what does electric field do? Electric field applies a force on the charge into field. That means if I have some electrons in between this region, those electrons will get applied by some force because of the potential difference, and they will get accelerated. So hence there will be some acceleration between these 2 points. Agree? Next, this entire setup is kept inside a vacuum tube. Reason is you do not want these electrons colliding with the air molecules to produce undesirable effects. So you don't want that. Okay, so there is one side through which you have a filament, and you connect this side to this side with a potential difference. So you apply some force, and this force is so strong because the potential difference is so strong. So this force forces the electrons out of this filament. It gets pulled because of the electric force. They get knocked out and they get accelerated, and when they have high energy, they collide with this target material. It need not be of tungsten, it could be of any other material as well. Yes, it can be of any other material as well. So basically these electrons go and hit the target, and once they hit the target, lot of energy gets lost. Some of the energy gets used to produce X-rays. The energy which gets lost in the form of heat, that is undesirable. So usually you have some circulating water to cool it down. So in order to cool it down, you have some circulating fluid which cools it down, and the rest of the energy goes into X-rays. So there is a transparent material or transparent glass plate here through which the X-rays come out. You can see that the target is kept at an angle, because when the electrons hit the target, you will see they will get reflected, and the reflection happens not via it's not the exact reflection of electrons, but the electrons hit there. What is ejected out is the X-rays. X-rays are photons, nothing but. Yeah, I hope this is clear. Very good, very good. So if you have understood till here, we will talk about what is the characteristic and what are the other things that are to be accounted for. Wave optics is there, Hariharan. It's there. Check it out in the Pathfinder playlist. Pathfinder physics playlist, you will find it. You might not find a special playlist for wave optics. That will happen later on. Okay, Hariharan? Yes, Lucifer, you can ask your doubt. Nick, H.C. Verma, D.C. Pandey, all of them, all right, they have the same kind of, formulas. Only the questions could be different. That's all. Okay. So this is a very good animation of what is happening. You can see how the electrons get pushed out from the filament and they hit the other side, the target, and in this case the target is rotating, but it's okay. That's the reason, because you want to take away the heat which is generated and throw it outside, and what you get over here are the X-rays. So that's the basic understanding of how X-rays are produced. Is that okay? Fair enough, everyone? Shall we do some questions based on this? So before going ahead, a quick revision. The energy provided by the acceleration of the electrons due to the potential difference, this energy, this will go into two things. Number one, into X-ray production, and some of it is lost as heat. If you are wondering how much energy will be provided due to the acceleration by the potential difference, that's simple. We all know if you take one electron, okay, if you take one electron and if you accelerate it by a potential difference of delta V, the energy, the kinetic energy that it will get is the charge into the potential difference. So this is the kinetic energy of the electron. Everybody agrees to this? charge into voltage is potential energy which it loses. That loss of potential energy comes as kinetic energy of that electron. As simple as that. Okay, so here is your first question. Can a hydrogen atom somehow emit X-rays? In the previous chapter of atomic structure, you have seen that a hydrogen atom shows Lyman, Balmer, Paschen, all these kind of series. Most of it lies in infrared, UV, visible light spectrum. So, is it possible that hydrogen emits X-rays? If it is not, then what is the reason for it? Think about it. Its energy levels are too close. Its energy levels are too apart. It's too small in size. It has a single electron. Is this the answer? Think about it. Now, if you want to really get to the answer, think, what did I tell you about X-rays? X-rays are very short wavelength, right? So X-rays are nothing but very short wavelength. So if the wavelength is small, then the energy of the X-ray photon, the energy of the X-ray photon is very high. Now, how do you get photons? I have told this to you in the previous chapter. If you have the nucleus, okay, so let's say this is a hydrogen nucleus. These are the orbits. These are the orbits of the electrons. Okay, the electron can jump from low to high, high to low. So if the electron jumps from high energy to low energy, then definitely you will get the electromagnetic radiation or the photons. Now, if you are not able to get it, that means this energy difference is not enough to match up to X-ray photons energy. Do you guys get it? The energy difference between the two levels of hydrogen is not big enough to create the energy required for the energy of a photon of a X-ray. So it is much smaller. So hence the energy levels are too close to each other. No, it is not B. It is option A, my warriors. It's not B. Energy levels are too close. Too close. Understand that. It's too small. This delta E is small, because of which it is much smaller than the energy of the X-ray photon. Hence, it cannot emit X-rays. Understand that. Got it? Very important question. This is also there in H.C. Verma's short answer, but obviously options are not there. It's asked differently, why you cannot produce X-rays using hydrogen. Next question coming up on your screen. Here it is. We have an X-ray tube. It is operating at 150 kilovolts and 10 milliampere. Only 1% of the power is converted into X-rays. The rate at which the target gets heated up is how much per second? Okay, in calories per second. Let's find this out. See, we all know that the electrons are accelerated via that potential difference, and some of that energy will get lost in the form of heat. Some of it will go into X-rays. Now, where do you supply that potential difference from? That is your electrical energy. So that is your electrical power. So the electrical power goes into accelerating it. That energy goes into heat and X-rays. Now, it is clearly mentioned that only 1% is converted into X-rays. So that means what? If 1% is converted into X-rays, almost like 99% is lost as heat. Almost everything. If it gives 100 joules of energy electrically, 99 joules converts into heat. Only 1 joule gets converted into X-rays. Interesting. So let's try to solve it. First of all, the power generated by electricity will be equal to, I'll find that out, voltage into current. So voltage is 150 kilo, right? So into 10 to the power 3 into current, which is 10 milli, which is 10 to the power minus 3. So this will be 1500, but watts. I hope this is fine. and out of this 99% is lost as heat. So the power loss as heat will be 99 by 100 times of 1500. But this is all in watts. Again, you remember that the question asked is in calories per second. Calories per second. Okay. Shri Harshit, just search for Shreyas sir cover 11th backlogs. You will find a session on that. Please watch that. Trust me. In fact, you will find 2 sessions on it. Backlogs 11th Shreyas sir. Just search for it on YouTube. You will get it. I had conducted it one last year and one this year recently itself. Now, what you do next? You do not want it in watts. You want it in calories per second. So you just take care of first of all these zeros. So 99 into 15 divided by almost like 4.2, that will give you calories per second. Because this is joules per second, 1 calorie is 4.2 joules. So convert joules to calories by dividing it by 4.2. Now what do you think will be the answer for this particular thing? Come on guys, what do you think? Sneha saying option C. Okay, most of the options are looking similar, only the decimal point is different. I think you can see this very easily. This is like 100, almost 100, and this is 15. This is almost like 100 into 15, and you have 4.2. Okay, you can shift the decimals if you want. So it will look like 1000 into 15, and this will be 42. Now I can just play around with this like this, 100 into 150, just shift 1 0 here, divided by 42. Now I know this number, 43s are 120, 42 into 3, 126. So it will be 3 point something. So it will be basically 100 into 3 point something. So whatever that something is there, when you multiply by 100, 2 more decimals will have to shift. So it will be 355, obviously. I hope that makes sense. So if it was 3.55, 3.55 into 100 will be 355. Is that clear, my warriors? That's how you do the math without actually doing the math. That's the best part of it. Moving ahead. I'm so glad you enjoyed this question and most of you were correct about it. Very good. Thank you, Teen Boy Fat. All right. Great. Sri Harshit, do watch that class and I'm pretty sure you will cover up your backlogs. Now, like I was telling you, the X-rays which are produced by Coolidge tube are of a very special kind. So let's go back. The Coolidge tube experiment. This is how the Coolidge tube experiment looked like, where you had the electrons bombarding a target and X-rays coming out of it. These X-rays are not of the same wavelength. They are all of different wavelengths. And when you plot the graph of the wavelength versus its intensity, that graph looks something like this. It looks something like this. When I saw this graph the first time, I was like, this looks to me like a dinosaur. Crazy dinosaur. I mean, I don't know. Have you seen that dinosaur? It looks like this. Maybe I can just draw its mouth over here. And this is how its tail looks like. And these are its feet. Sagittarius. Wow. Yep. So remember, this X-ray graph looks very similar to a dinosaur. Yeah. Isn't it? Yeah. Cool. Now I need to understand, number one, why is the graph ending over here? Why is the graph ending over here? Number one. Number two, I want to know why this graph has thorns and why this graph extends till infinity. So 3 questions I want to answer. Thank you, Geeta. I want to answer why there is a cut over here, why it stops, why it extends till infinity. Second. Third, why are there thorns over here? And that tells me that, you know, the way to analyze the graph correctly would be to separate out 2 different things. Number one, just imagine a dinosaur. Just imagine a dinosaur. Okay, this is our dinosaur, which has a smooth skin like this. This is, oh my god, it doesn't look like a dinosaur. It looks like a worm, creepy worm. Okay, so A dinosaur without the thorns, that's a smooth one. So you can see a smooth part that is called as the continuous spectrum of the X-rays. And just imagine a dinosaur with only thorns, only one backbone, and that's it, 4 legs, that's it, and only the thorns. So these thorns are categorized as the characteristic X-rays. Characteristic X-rays. Hi Tabu, join in. Oh, somebody saying tortoise. Yeah, maybe. So let's understand why that smoothness come, and let's understand why the thorns come separately. First thing, continuous like tortoise, smooth skin. You can just pet the dinosaur like this and it will feel very happy. If you just put your hands on the skin of that dinosaur, it will be very happy. Trust me on that. I have done that long time back. Yeah, when I acted in Jurassic Park. Yeah, many of you don't know, I acted in Jurassic Park a long time back. Yeah, played with dinosaurs. I had a fun time too. I'm just waiting for the next Jurassic Park to be released. They haven't called me yet. Let's see when they call. Anyways, continuous spectrum. So how does it happen? First, when these electrons get accelerated, they are going to collide with that target material. Target material is made of atoms. Look at one such electron. Look at one such electron. Coming from the accelerated part, enters, hits the target, gets deflected because of the charges out there. Gets deflected because of the charges over there. Once it gets deflected, that means it has got accelerated. And what happens when you accelerate charges? You will see electromagnetic radiation. According to Maxwell, you would have seen that in chemistry back in atomic structure. A charged particle, when accelerated, it will emit radiation. That is basically photons. Is that making sense? Very good. So what happens is that when the charges get accelerated, decelerated, doesn't matter, you will see there will be a photon which is emitted. And these photons are not of a specific wavelength. They are of variety of wavelengths. Reason is, I don't know how much energy it can lose. It can lose less, it can lose more. So imagine this. Just imagine this, all right? I'll put it up for you. So imagine this is the kinetic energy of the electron. That's the max energy the electron can have. This is your zero energy. So once the electron gets deflected because of the charges, and you see there is a loss of energy by the emission of radiation. So maybe it loses this much energy. Maybe it loses this much energy. Maybe after passing through some other atom, maybe it loses this much energy. Maybe when it passes and deflects through other atom, maybe it loses this much energy. Maybe some other electron might lose only this much energy, then this much energy, maybe then this much energy, and then this much energy, and then this much energy. Some electron might lose all the energy at once. Some electrons might lose it in multiple steps, maybe 2 steps, 1 steps, I don't know. Some electrons might lose it in more steps like this. Okay, I don't know. These are all the different possibilities. Now, do you remember that energy of a photon is hc by lambda? So the loss of that energy will be the energy of that photon, which is hc by lambda. So more the energy loss, less is the wavelength. Less the energy lost, more is the wavelength. Is that clear? Is this clear, my warriors? Hi Nishu. Yes, this is an English channel. I can teach in Hindi, but I am teaching on English because, you know, this is an English channel. Alright. Now, think what are the most extreme situations. Think about the most extreme situations. Extreme situation is when small energy is lost. That means delta E tends to 0. When delta E tends to 0, like the ones over here, when delta E tends to 0, then lambda, if this tends to 0, what will lambda? Lambda tends to infinity. Agreed upon this? Lambda tends to infinity. Isn't this the max value of wavelength. So this is the maximum wavelength that can be emitted when small amount of energy is lost. Next extreme case. Second extreme case is instead of losing it in small parts like over here, the max energy lost is over here. Can you see that? This one. This is basically delta E is maximum. It can't be more than this for sure. Hence, if delta is maximum, lambda is minimum. So hence, lambda will tend to its minimum value but not zero. This is very important. Understand, delta I will tend to its some value, maybe a 500, 200, who knows. So if you put that value 200, 300, 500, you will get the lambda value, but that is the smallest wavelength that can be created. Smallest wavelength means largest frequency. You can't get a frequency more than this. You can't get the photon's energy more than this because the electron lost everything that it had. This transition, it lost everything. Like, okay, take everything. Highest energy, maximum frequency, smallest wavelength. It can't give smaller than that. Sorry, boss. It only had that much. Is that understood? So, there are two extreme cases. First extreme case, it loses in steps. Deflects. Small energy loss. Small frequency. Large wavelength. That's number one. So, max wavelength is infinity. The other extreme case is it loses everything it has. It gives out maximum energy photon. That means wavelength will be the least. As simple as that. Very good. So I will put it up here for all of you. Very, very interesting theory. Just putting up for all of you. If this is the kinetic energy of the electron and if this is your zero energy level, then you can have multiple situations. So one such situation is shown over here. Then you can have situation like this. You can have situation like this too. Okay. So the most extreme situations are as shown. Number one, it loses in small numbers. So many deflections, and this case delta E is minimum and tends to 0. So hc by lambda tends to 0. So lambda max tends to infinity. The other thing that can happen is it loses at once. Lost energy delta E is max, and therefore this is equal to hc by lambda minimum. Very, very important. This is the least wavelength. Sometimes it is also called as the cutoff wavelength of the X-ray spectrum. Okay, so what is this called? Sometimes this is also called as the cutoff lambda of the continuous X-rays. It can't get smaller than this. Now if you rearrange and play around with this, it's very simple. Where do you get this lost energy of the electron? From the kinetic energy of the electron. That means charge into potential difference. So can I not say charge? Oops, I know what the value of the charge is. It is nothing but E. So E into potential difference. Can I not say it is hc by lambda minimum? Very interesting equation. Something which you should be aware of. It's not difficult to remember, but you need not remember also. Reason? Come on. Energy due to acceleration, charge into potential difference is equal to energy of photon, hc by lambda. As simple as that. Abhishek, I'm very good. Okay, very good. Abhishek MB, I have changed my background long time back. I had made a community post that I'm going dark, and there I go. Yeah, you can get all the notes available in the Telegram channel as well. Make sure you join it as well. Okay. Yeah, Ajay Kumar, Thangaduri, have I shaved or something? Yes, I did shave. But I'm also cultivating few crops. Okay, right now I've just plowed the field and I can expect some fruits maybe in few days. So yeah, that's what I'm doing. Anyways, now if you rearrange this, what happens? You can see very interesting thing. I'll just rearrange this, observe. So lambda minimum will be HC by E into delta V. Now if you remember, HC had the value of 1240 if you express it in nanometers, and if it was in Armstrong, it was 12400. So you can write it as 12400. This will give you the answer in nanometers, but this will be in electron volt. So that electron and electron below will cancel, and only thing left will be delta V. This is supposed to be only in volts. Okay, so if it was 12400, then it is just nanometers. If it is 12400, then it is Armstrong. I'll just put Armstrong over here. So if it is just 1240, only then it is nanometer. It is nanometer, and that 12400, that is Armstrong. Remember that conversion, but that had E over there. So that E and this E will get cancelled, and this will give you delta V, which has to be in volts. Keep this in mind. Very, very important. Excellent. All right. Everybody clear? So this can be used for calculation purposes. Let's solve some question based on this. The shortest wavelength of X-rays emitted from the tube depends on which of the following? The shortest wavelength, the current in the tube, the voltage applied to the tube, the nature of the gas in the tube, the atomic number of the target material. If X-rays passes through prism, ideally we should expect that dispersion should happen, but X-rays have very low coefficient, or rather, refractive index almost close to 1, so they will hardly refract. X-rays are known to just pass through different mediums without bending, so there will be hardly any dispersion. You can't see that, Abhishek. Okay, so Sneha saying C. Let's see what do you guys say. Akash saying B. The shortest wavelength of the X-rays emitted. The shortest wavelength, I just told this to you right over here. Okay, this is the lambda minimum. This depends on, now we saw the lambda minimum comes because of the voltage difference. You can see H, C, E, they are all constant. It only depends on the voltage difference by which it has been accelerated. Hence, the correct answer should be the voltage. Okay, if I ask you, what will the current do? If I increase the current, what happens? More electrons will come. If more electrons will come, does that affect the lambda minimum? No. It will just increase the number of electrons, that will increase the collisions, that will just increase the X-rays. So the number of X-rays produced will be more, but it will not change the curve. It will just probably increase the intensity. More intense beam of X-rays will come. So that's what it does. There is one interesting thing which the target material does, and that's what we are going to see next. When you change the target, the continuous X-rays does not get affected, but you will see that the characteristic X-rays will affect it. So very important things that you should know. Sometimes these questions also can be asked. This will change the intensity. This will change the intensity of the X-rays. Okay, then what does this do? This will affect the characteristic X-rays. Okay, the nature of the gas, it will not do anything, guys. It's irrelevant to the production of X-rays. Ideally, you should not even have any gas inside the X-rays. That's bad. Okay, next question coming up on your screen. Okay, there we go. For NCERT exam, is the flash series sufficient? Well, yes and no. I would suggest you to watch the latest series, which is the Pathfinder, because again I have covered everything in detail, so you might as well learn a little bit more, twin gamers. Alright, so an electron having de Broglie wavelength of lambda falls on the X-ray tube. The cutoff wavelength of the emitted X-ray is interesting. So let's visualize the scenario. So there is this electron and it's moving and it collides with the target, and you can see X-rays coming out of it. So the question is, what's the cutoff wavelength? That means the lambda minimum. What is given in the question is the de Broglie wavelength of the electrons. This is de Broglie wavelength. Be careful. Let's see how to solve this. If I know de Broglie wavelength, I can find the momentum of the electron. The momentum of the electron will be h by lambda. If I know the momentum of the electron, can't I find the kinetic energy of the electron, which is p square by 2m, which is h square by 2m, and you will have lambda square. Now where does this kinetic energy go? This kinetic energy goes in producing those X-rays. And remember that kinetic energy, when maximum amount is lost, then you get maximum energy photon and you get the minimum wavelength. So when max kinetic energy is lost, what do you get? You get minimum wavelength X-ray, which is given by hc by lambda min. Now just equate both of them and just figure it out. So shift lambda minimum on the top. So when you shift lambda minimum on the top, what is remaining? hc is remaining from here, and from here that h square has come below, and 2m lambda square has gone on the top. Now you can see so many things will get obviously cancelled, like this h, and you will have 2m lambda square c by h. 2m lambda square c by h, that's option A, I suppose. Yep, very good Abhishek, I like your spirit, bacha. Yes, option A is correct. 11th CBSE will not have board exam, you have school exam. Is this understood? Clear, my warriors? Beautiful question. And how de Broglie's wavelength, how wave particle duality has been converged with this chapter of X-rays. Okay, moving on to the characteristic, the thorns of the dinosaur. So I just told you that one type of X-rays that you get is the continuous X-rays. It has a minimum wavelength and maximum is infinity. The second X-rays are those thorns. They are very peculiar because they are suddenly spiking up and going off. Suddenly, for certain wavelengths, recollect over here in this diagram, suddenly you have certain X-rays of large intensity. So why do you get these spikes? That can be explained via this process which I am showing over here. Observe this simulation. Hi Mansi. Imagine an electron, okay, which is very energetic. Instead of just getting deflected, by chance, because of its high energy, ends up reaching the inner shells. See, if the electron has low energy, it can't pass through the shells, the outer shells, and reach the inner shells. That's not possible if the energy is less. But if the energy of the electron is more, and why is the electron energy more? Because you have accelerated it by a large amount. So then it can pass through all the gaps. It hits one of the electrons inside and it knocks it out. Look at that, it got knocked out. When it got knocked out, there is a void, there is an empty space created in the inner shell. Will the atom like it? Obviously not. The atom will not like the empty space. The moment that happens, an electron in the upper shell, upper orbit, will jump to fill that gap. And what happens when electron jumps? We know that electromagnetic waves, that's a photon is emitted. Hence, you will see that as soon as that empty void is created and the electron from higher shells jump into it, you will see that a photon is created, and that photon will be in the range of X-rays. Now, probably you will understand why you get the spikes. Think, in atomic structure I told you, every atom has a unique signature, as in defined energy levels. If you see the energy levels of iron, it's completely different from zinc. It's completely different from hydrogen. It's completely different for lithium. Every atom has unique energy levels. So if every atom's energy levels are unique, and if an electron jumps from higher energy to lower energy to fill that void, that means those jumps are also unique in nature. The energies are also unique in nature. And because they are unique, the other word for that is characteristic. Hence the name characteristic and the sudden spikes. Those photons are so peculiar because when you change the element, those spikes will also change. And you will see that the target material decides what kind of photon gets emitted by the electron collision with the atom. Is that understood? So, the name characteristic X-rays. So, when highly accelerated electrons strike the atom target and knocks out the electrons in the orbit, there is a vacancy created, and this vacancy is being satisfied and overcome by the jump of the higher energy electron to the lower energy orbit. And that's how you get X-rays from this. Very good. Alright, Ramya will talk about this in nuclear physics for sure. If you give more energy, can we remove the proton? Very interesting question, Kiran. So, the thing is, for reaching the proton, it requires even higher energy, that is called as fission. And when you bombard it with very high energy and it reaches the nucleus, it might even explode, it might split the nucleus. But electron having very small mass, the chances are less, but that is possible using neutrons. Okay, so you can split the nucleus and you can have a fission reaction out there just by giving it very high energy. But here that energy is not so high also. It's just enough to knock out an electron in the inner shells. That's it. Okay, glad to know that, Mansi. Hello A Sinchana channel, welcome aboard. Now, there are very important things that you need to know over here. See, just because there is a vacancy, there is a jump from higher orbit to lower orbit. So let's say for example, okay, there is a jump which occurs from here to here. Can you see that? There is a jump over here. That jump is basically this jump, the electron jump from higher energy to this vacancy. Now if you want to know where the vacancy is, this is your vacancy. Okay, this is your vacancy which is created. So vacancy is created right over here. Hence, you will see that X-rays are created. So you will see EM waves are created out of this. Now the energy of this X-ray photon, the energy of the X-ray photon will be exactly equal to the energy difference between the orbits of that atom. So it's basically E high minus E low. That will be the energy of the photon, and energy of the photon can also be written down as hc by lambda. But this lambda, keep in mind, it is characteristic. It is not any random lambda, unique. If it is from this to this, one lambda. If it is from this to this, some other lambda. So lambda depends on the nature of the jump. Yep. Now, oh no, Abhishek, sun undergoes nuclear fusion. Fusion is different. Okay. Now, one more thing you need to remember. If this equation is clear, this probably might ring a bell in your head that, yeah, this was also studied in an atomic structure. Remember, we studied one formula which was based on the Rydberg's constant. When an electron jumps from N1 to N2, the wavelength which is created, 1 by lambda, is R Z square into 1 by N1 square minus 1 by N2 square. So you can also use that formula to find this lambda, the characteristic lambda. You can use R Z square, and you can use 1 by N1 square minus 1 by N2 square. It's perfectly fine. because this was actually derived from this. But there is a small catch. The catch is that all these formulas are valid for Bohr's model of atom, and we know when the element becomes very heavy, Bohr's model is not even valid. So this becomes a very approximate formula for very high energy for very heavy metals, because Bohr's model will not be valid. But it's okay. Okay, fair enough. Let's move ahead to the nomenclature part. What happened, Manoj? What did you do? What happened? Something went wrong. Hi, Nikhil. Maybe we can have a chat, Manoj, towards the end of the class. You can stay back. Now, what is the nomenclature? Very important. If the vacancy is created in K shell, then to fill it up, you need a jump from higher orbit to the K shell. Then the photon which is emitted is called as the K series photon. So what is a K series photon? Vacancy is in K shell. An electron from any other shell jumps from higher shell to K shell. Those wavelengths which are emitted, they are the K series. If the vacancy is in L shell and an electron from higher shell jumps over here, you will see that the wavelengths which are created, they are called as the L series. This reminds me of Lyman, Balmer, Paschen, and so on and so forth. But I will not call it that. Reason? This is not hydrogen. This could be anything else. Hence, the generic nomenclature is K series, L series, M series, N series, and so on and so forth. Easy? But now you might be seeing a subscript over there. Alpha, beta, gamma, delta. Why are you having that? Simple. Alpha means it has just jumped from the next available shell. So if it jumps from L to K, then it is K alpha. The next available is beta. The next available is gamma. So that's how it works. So how do you go ahead with it? Understand? If for example, it jumps from n is equal to 3 to n is equal to 2. What is n is equal to 2? It is L shell. Now from 3 to 2, it has now become a L series wavelength. 3 is the next available shell after n is equal to 2. So this is basically L alpha. So if it jumps from n is equal to 3 to 2, it is called as L alpha. If it jumps from n is equal to 4, then it will be called as L beta. That's how you name it. Hello Priyanshu. Lockdown Entertainment. Oh my god. Crazy name. Hi Godson. Hi SR Darren. Hello Maxi. I'm very good. Join in Bacha Log. You belongs to which state? I belongs to solid state, but 80% liquid state. But otherwise, right now I'm in Karnataka state. Interesting. Okay, so keep this in mind, guys. Very important nomenclature that you should know. So if you actually label these peaks, this is how it looks like. Look at it. Definitely, Muthuraja, I will definitely respond to all the doubts or any queries that you have. Please put it up in the comment section after the video and I'll definitely respond. SR Darren, it's there in the chat, in the description box. It's there in the title itself. Hopefully you can find it. Anyways, so this is how the K series, L series and M series look like. I have a question for you though. Why is the K series here? Why is the L here? And why is the M there? Why isn't the K there, then L and then M? Probably the answer lies over here. K has very large energy. L small, M even smaller. If K has largest energy, that means the wavelength should be the smallest. Is that clear? Very good. So, hence K will come right over here. Observe that. K will come here, then L and then M. M has the smallest energy, hence largest wavelength. This is wavelength, this is intensity. Next peculiar thing to note about the graph. It is basically alpha, beta, gamma. Notice alpha comes there, then beta, then gamma. Alpha, beta, gamma. Alpha, beta, gamma. Alpha, if there was beta and gamma, it will come like that. Why is alpha right, then beta, then gamma? The answer comes right again from the graph. Alpha has the smallest energy, beta has the largest energy, then gamma even more than that, delta even more than that. So alpha having the smallest energy, it has the largest wavelength of that group. Hence, you will see that alpha has large wavelength because it has small energy. As you go ahead, their energy decreases, so you will see it goes on to the other side. Understood, my warriors? Very, very important things that you can note from the graph. All right, let's solve this question coming up on your screen. Here we go. The wavelength of K alpha X-ray produced by X-ray tube is 0.76. The atomic number of the anode material of the tube is. The question is, what's the atomic number? So read the question. The K alpha. K alpha means what? K alpha means it has jumped, going back over here. It has jumped from n is 2 to n is 1. So going over here back. So the question is, if the wavelength is given 0.76, then what is the atomic number? Now the way to solve this question is, first of all, if K alpha means n is equal to 2 to n is equal to 1, so the wavelength of that photon which is emitted, if it is 0.76 Armstrong, I think I know which formula to use. Which is the formula that you will use, guys? Obviously very simple. 1 by lambda is equal to r z square. 1 by n1 square minus 1 by n2 square. Just have to use this to find z. Everything else is known. So let's solve this question. I want to find z. I'll keep that in mind. So 1 by lambda. Lambda is 0.76. So 0.76 into 10 to the power minus 10 is equal to Rydberg's constant. I can roughly put it as 1.1 into 10 to the power 7. And then z square as it is. And then 1 by 1 square minus 1 by 2 square. So this will become 1.1 into 10 to the power 7 into z square. 1 minus 1 by 4, that's 3 by 4. So I want z square. So z square will be, shift this guy below and shift 3 by 4 over there. So it will become 1.1 and 0.76. 0.76 into 1.1. 10 to the power minus 10 and 10 to the power 7. So when you multiply, you will get 10 to the power minus 3. 4 goes on the top and 3 comes below. This is roughly what you will get, I suppose. Now it's all about approximations. This is z square. I want z. So probably this is what I will do. 0.76. 0.75 is 3/4, right? 0.76, 0.75, roughly the same. So how about this? 0.76, I will write it as 3/4. This is fine, 1.1. 10 to the power 3, maybe I'll put it on the top, so 1000. And that 4 which is there on the top, I'll bring it below. So again, it will become 3 by 4. Interesting. Great. Now, 3 by 4, 3 by 4. So if I shift it on the top, it will become 4 by 3 whole square into 1000. I can write it as 10 square. Okay. Into 10 by 1.1. 10 by 1.1. Is that making sense to all of you? Is that making sense to all of you? These are all decent enough approximations because 0.76 is roughly 3 by 4 only. 0.75. Okay. Now I don't want z square. I want z. Because I have put in square form, I can write it like this. Z will be root of this, which will be 4 by 3 into 10 into 10 by 1.1. Roughly 1.1, you can give or take it as 1. It's fine, right? So roughly, approximately, slightly less than 10, but it's okay. I'm just taking a guess. Now 4 by 3 is roughly 1.3, okay, into 10, and root of 10 is pi, or 3.14, 3.14, okay. Now interesting thing to note, this is 13, so 13 into 3.1, 13 3s are 39, so very, very close to 40, and 40 is there in the answer. Got it? How we did this calculation? We did not actually sit and find out the square root. We did not actually sit and calculate these multiplications and divisions. I just made some manipulation. As simple as that. Is that understood, my warriors? Very, very interesting solution, I suppose. Okay, and if you have loved it, go smash the like button in case you have forgotten to smash the like button before entering the channel. And yes, go hit the subscribe button because that's how you get your daily dose of lectures, strategies and all other important topics. Moving to the next one. There is an X-ray coming from a Coolidge tube, that's your standard setup, against the wavelength lambda as shown in the diagram. The minimum wavelength is lambda c and the K alpha wavelength is lambda k. If the voltage is changed, what happens? Very important. For continuous waves of X-rays, remember Hc by lambda min was E into delta V. So, if at all the accelerating voltage is increased, that means delta V is increased, lambda minimum will decrease. Therefore, I can easily conclude that the minimum wavelength lambda c will decrease. Okay, lambda c will decrease. Number one. Next important conclusion is that K alpha. So for characteristic, the lambda depends only on one thing. If you have failed to notice that, if I go back over here, this lambda characteristic depends on the transition and the target material. So lambda depends on the target material and the transitions that occur, but not on the accelerating voltage. Hence, it is independent. Therefore, it is independent of the voltage difference. Therefore, lambda k alpha is basically the same. So now, if that's the same, you can easily guess it. Lambda k is same. Lambda c will decrease. So lambda k minus lambda c will increase, I suppose. It's option A, I suppose. Check this out. Here, this is same. This value will decrease. So if you subtract less number, you will have a bigger value. Make sense? Is that clear? This is same. This decreases. Fair enough, I suppose. Very good. Let's move on to the next one. Now, let's talk about Moseley's law. What is Moseley's law? See, based on these experiments, Moseley saw that we can probably plot some interesting graphs for different elements and notice the characteristic X-rays and see some particular trend. Long time back, people used to arrange the periodic table based on the atomic mass number. They thought atomic mass number was the fundamental quantity. Later on, because of Moseley and because of the discovery of X-rays, it was understood that the fundamental characteristic of an element is not mass number but the atomic number. That's the number of protons in the nucleus. How did he arrive at this conclusion? He took the characteristic X-rays, because characteristic X-rays were completely dependent on the target. That means if you change the element, the characteristic X-rays changed. And then he noted down their characteristic frequencies, not the continuous. It's not important. So what he found out was very fascinating. He found that if you just rearrange this, so remember 1 by lambda of the characteristic is R and Z, and then 1 by N1 square minus 1 by N2 square. He also considered one more effect called as the screening effect. Remember screening effect? You would have learnt in chemistry. Because of the inner electrons, the perceived charge is less than the actual charge. Imagine this. If the nucleus has plus 5 charge, okay, you will say that yes, the nucleus has plus 5 charge. But if there is an electron revolving around it, forming a cloud, the perceived charge will be just +4 because that electron will shield it. That's how it works. So if this much is understood, what I will do is I will add a screening constant. He took into account that screening constant as well, and we know that lambda and frequency are related because lambda into frequency is speed. So 1 by lambda, you can see that frequency by c is equal to 1 by lambda. So just substitute it over here. Therefore f, this is characteristic by c, is equal to r into 1 by n1 square minus 1 by n2 square, and this is nothing but z minus screening constant whole square. Rearrange, you will get f star, that's the characteristic, it will be rc into whatever this is, the transitions, okay, and you will have z minus s the whole square. I can take root on both sides, and this will become root of that characteristic frequency is equal to root of rc into 1 by n1 square minus 1 by n2 square, and that square goes off, so we'll just have z minus s. From this equation, what he did was he plotted the graph of root of frequency versus z. So root of frequency was taken on the y-axis and z was taken on the x-axis. Reason? It will become a straight line because this whole thing is a constant. rc 1 by n1 square minus n2 square, these are all constants, and s is also a screening constant. So he found that the y versus x graph was a straight line. We all know what a straight line equation looks like. It should look like y is mx plus c, correct? Hence it should look like a straight line, and that's what he got. Look at this. These are the k alpha lines for different elements. K alpha means n is 1 and other n is 2. Then he plotted k beta for other elements, L alpha, L beta. He saw all of them are straight lines. So what is that z? Z is atomic number, not mass number. So that's how we concluded that yeah, these are characteristic lines. Even if I take an isotope, it falls on the same dot. So for different isotopes also it fell on the same dot. Only z is what changes the wavelengths or frequencies. That's how we concluded that atomic number is more fundamental than atomic mass number. Okay, I have put the derivation as well for you. So more often than not, the same equation which I just gave you over here, this entire thing is just called as a constant A, and this screening constant is called as B. So you will see it in this fashion. So root of the frequency is A into Z minus B. It's the same thing. So this B was your kind of screening constant, and A was that whole bunch of numbers right inside this bracket. RC into 1 by n1 square minus 1 by n2 square. Is that clear? Fair enough, guys? Do I need to remember the value of A and B? No, it will be given to you. Okay, so don't worry about it. Fair enough. Let's go ahead. Some of you might be thinking, what is this symbol? I just gave you F. F is frequency. Nu, this is not V, this is nu. Nu is also frequency. K alpha wavelength emitted by an atom of atomic number Z, which is 11, that means atomic number is 11, is lambda. What is the atomic number that emits the same K alpha radiation for a wavelength with a wavelength of 4 lambda? So there are two different targets, different Zs. Obviously their K alphas will be different. First K alpha is lambda, the other guy's K alpha is 4 lambda. The question is, what is the other guy's atomic number? All you need to do is a simple thing. Root of F is A into Z minus B. This is your Moseley's equation, but the question is about wavelength, and we know that frequency and wavelength are inversely proportional. So from these two equations, what will I get? Root of wavelength is inversely proportional to A into Z minus B. Cool? Next, if I divide it lambda 2 by lambda 1, all I will get is, oops, I don't need that root. I don't need that root. All right, so what will I get? I will get Z2 minus B and Z1 minus B over here. Now lambda 2 by lambda 1, I think I know. The new wavelength is 4 lambda, the earlier one was lambda. So this will become 4 lambda by lambda. Next, Z1 is 11, so 11 minus, and Z2 I do not know, minus B. Now you might be wondering what is the value of B. Usually the value of B is 1. I'll tell you why. Let's go back to this equation over here. Z minus S. Remember what was S? S was the screening constant. What was S? I told you it was the screening constant. For K alpha. Now what is K alpha? For that again let's go back a little bit. What's K alpha? K alpha, the electron jumps from here to here. There is a vacancy here. There is a vacancy in the K shell. Usually in the K shell, how many electrons are there? In the K shell, usually how many electrons are there? Just answer this. 2, right? So, if there are 2 electrons, and there is one vacancy, that means 1 electron is not there. That means only 1 electron is here. That means when the electron jumps from here to here, think about it, what is happening? Think about it. This is your nucleus. There is only 1 electron here. There is one vacancy, and the electron from the higher orbit has jumped over here. So what is the effective charge of the nucleus? What is the effective charge of the nucleus? Whatever Z was there, minus 1. Because the nucleus obviously has positive charges and this electron has a negative charge. So one charge will be minused. I hope this makes sense. Is that clear? So hence the screening constant will be 1. Yeah, hence the screening constant. Where did we go? Was it here? Okay, so yep, the screening constant will be 1 for K alpha. So hence the value of B will also be 1, and therefore I can just put the value of B also over here as 1. That's it. Now it's done. What is delta radiation in K shell? So delta means just go to that chart. Just go to that chart. You will understand it. It's very easy to understand from the chart. Alpha is from 2 to 1. Beta is from 3 to 1. Gamma is from 4 to 1. Delta will be from 5 to 1. Understood? That's how the numbering goes. Fair enough. So there we go. And we should be able to get the answer in the next step. Alright. So we have 4 lambda by lambda. That's root of 4. That's 2, I believe. So 2 is equal to 11 minus 1, which is 10, divided by Z2 minus 1. So Z2 minus 1 is equal to 5. So Z2 is equal to 6. That's how you do this. Thank you for all the love from Uganda. Eknath, no mentee bacha, but it's a problem solving session. Usually we conduct mentees for lower grades, but since now you're all grown-ups and you don't find the thrill by just looking at the mentee scores, you get the thrill by a mock test and solving actual books with lots of questions. So I hope you derive the thrill by the actual good level questions being conducted here and all the other books that you have. The last part, emission of delta radiation. In what context, Ramya? Okay, so maybe I can help you with that then. X-rays are very, very small wavelengths, and I have also told you what is diffraction. Diffraction is the spreading of light. And when does diffraction occur? When you pass EM waves through holes or through gaps. And peculiarly, when the gaps or the holes are of the size of the, when the gaps or the holes are of the size of the wavelengths, then the spreading is even more. Now, atom to atoms also act like gaps. So imagine a solid. So a solid is full of atoms. Each atom with the neighboring atom has some gap. Even that gap acts like a slit, acts like a hole, acts like a barrier with some opening, and when light passes through it, even light will diffract. But not every light will diffract, only those lights of that wavelength, of that gap, will be able to spread more. It so happens the spacing from one atom to the other atom is in the order of angstroms, and because angstroms is also the wavelength of X-rays, hence X-rays are the ones which get easily spread when they pass through atoms. And that's the reason why you will find that X-rays are used to pass through atoms or through solids so that they spread, and looking at their interference pattern, you can guess what is the structure, what is the spacing between these atoms to atoms. So hence X-rays are used to figure out the structure and study the structure of solids or crystals. So you have this diagram which shows you X-rays falling on a solid surface, and you will see the light will spread, and two such rays are shown over here which eventually merge using some lens or when observed under a microscope, and they will interfere. You will see these two X-rays will travel different distances. Because they travel different distances, like the one here travels more, the one here travels less, there is a path difference which is created. Lambda is the wavelength of the X-rays, theta is the angle at which you are making the light or X-rays fall with the surface of the solid, d is the distance from one plane to the other plane, so interplanar distance between the crystals, molecules or atoms. Then the formula which is given by Bragg to find out what kind of interference occurs, is given by n lambda is equal to 2d sine theta. Very, very important relationship. Theta is the angle which the X-rays make with the interplanar layers or the surface. D is the distance between those two atoms of two planes of that crystal. Lambda is the wavelength of the X-rays. N is the order of interference, first order, second order, third order. So n lambda is 2d sine theta. So usually you will know the order and the wavelength, and you will also know the light being incident at certain angle. From that you can find d, and you can find out the distance between the two layers of that crystal. So that is Bragg's law of diffraction, to find out or study the interplanar molecular distance between atoms of a solid. Very interesting. Let's solve a question based on this. Here we go. If X-rays of wavelength 100 angstrom is incident on a crystal surface normally, then what should be the value of d for the first order spectrum? Let's do this. So there is a surface and the X-rays are incident normally. If the X-rays are incident normally, then the value of theta is basically 90 degrees. Just using our formula, n lambda is equal to 2d sine theta. Since it is mentioned first order, n is 1. Wavelength is 100 angstrom, so into 10 to the power minus 10 is equal to 2 into d. D is something which I do not know. Sine of 90. Sine 90 degrees is 1. So naturally d will be 100 by 2, which is 50 into 10 to the power minus 10 meters. So do I have it? Yes, this is nothing but 50 angstroms, which is there in the option C. Correct, Sneha? Okay. Oh my God, Ekant, you are too early to be here. This is one of the last chapters of 12th standard. Option C is correct. Now I have put up some questions for you for homework. This is a very small, sweet chapter. This year I am expecting a lot of questions from X-rays. Even in the Advanced, there could be a question from X-rays, even in boards or even in NEET. Trust me when I tell you, I've seen so many questions in the last year which were asked from modern physics. Sometimes they ask a combination question, dual behavior or photoelectric or X-rays or atomic structure, all of them combined. So you can never be sure which kind of question can be asked. So the entire of modern physics, which is quite small, sweet, and also very easy to understand, also helps you a little bit in chemistry. I think you should do it. So solve these homework questions. This was the second homework question. Put up the answers in the comment. This is your third homework question. This is your fourth homework question. And this is your fifth homework question. So this is like your assignment which you get for free every day. But yes, you want more questions? Yep, I'll be sending the PDF in the Telegram. There is a Telegram link which is there in the description. So I'll just show this to you, where and all you can find all the links in the description box below. So if you're watching this video right now, just go below over here and you will see right over here, join us on the Telegram channel. So click on this, you will get the PDF with my handwritten notes. Now you can also show your support by downloading this and changing your display picture of your YouTube account. It means a lot. It shows that you're loyal, you're regular. So go ahead, download this picture, change it. So just like I have changed my YouTube display picture, and you can find it over there. Then you can see these are the course links. If you would like additional practice problems, you want mock tests, and you want the entire 11th and 12th to be covered in the next few days before your board examinations. So if you click on the JEE crash course, you can see, you can select your target exam. There is NDA crash course as well. There is CBSE term 2 crash course as well, with assignments, with mock tests, everything, and doubt solving for just 6,000 rupees. So if you just click on it and just enter down your login details, you can create your account for free, obviously. Also, you have the JEE crash course right over here, and you can see this has just started on 31st of Jan, but you also have an option to join the current batch. Remember one thing, you will not miss anything even if you join here, because the sessions also get recorded. Also, you will get 20 tests and also a chance to compare your ranks with the All India ranks. Also, the competition can be judged looking at your report cards. These report cards are in detail, plus you get doubt solving unlimited till the last attempt. And these lectures are available not till the first attempt, till the last attempt. No matter how much it gets delayed, no matter how many attempts happen, you get all this material till your last attempt. And this course is not for 9,000. Actually, when you go and click buy now, you will get this for 8,000 rupees. Okay, that's the advantage of my coupon code. Make sure you use my coupon code so that you will see that you get all these benefits, and you will get this at an affordable price of just 8,000 rupees. So go ahead, join it right away. I will be waiting to see all of you in the crash course as well. Bye bye, take care, have a great time. Good night, teen boy. Bye bye, Sneha. Bye bye, Ankit. Bye bye, Patipatan. Mohanty, welcome. Take care, and I'll see you guys in the next class for modern physics, and I'll be doing nuclear physics. That's radioactivity, the study of the nucleus and all of that. And if you still have some doubts which you want to ask, please let me know in the comment section below. Take care. Hasta la vista. This was Shreyas here.